So now we will going to consider a stepped bar. So what is the stepped bar? So we will consider a stepped bar of having different cross-sectional areas and having different lengths. So this is which is a stepped bar. So this is the member which we are considering is subjected to an axial compressed axial tensile load, which is P here and this is also P here. Now having lengths L1, L2 and L3, having the cross-sectional area A1, A2 and A3. So this is the section 1 and this is the section 2 and this is the section 3. So let P be the axial tensile load which is applied for the member and E is the Young's modulus. Let P is the axial tensile load applied, and E be the Young's modulus. So here, so what we are considering the Young's, why we need to consider the Young's modulus is basically because to identify what is the nature of the type of material which we are considering. Since it is a stepped bar, all the sections is made out of the same material, so we will going to have the same Young's modulus for all the cross sections. And since the diameter is changing at each point on each sections, so naturally the area of cross section at each section will going to keeps on changing. So that is the reason why we have A1 into A3. So what we need to find out is the stress and the strain. So what is stress? So since the load, the tensile load is applied at the two ends, so the load will be considered uniform at many sections when you are considering. So naturally the load will going to remain the same. So that is the reason why P will be axial tensile load. So now we will going to consider what are the different types of what are the stresses which will going to which will be applied at the different sections. So we have one point which is section 1, which is the section. Then we need to find out the stress. Then we have the strain. Then we have the Young's modulus, strain, and we have the elongation or the extension. So we have the extension, elongation. So now we will be considering this for the first section. So what is the first section we are considering? The first section we are considering here is this section 1. So when we are considering the section 1 here, this is the section 1 wherein section 1 having the cross sectional area is A1 and having the length L1. So naturally we have the load which is applied the tensile load. So here also we are going to apply the tensile load. So naturally what will going to be the section 1, the stress. The stress is given by sigma 1. So the sigma 1 will be P by A1. So where A1 is the cross sectional area of the specimen. Now when we come to the strain is given by epsilon 1. The strain is given by, so what is the condition for the strain? The strain which we are given as the Young's modulus, which is going to be the stress by strain. Since I want strain, epsilon will be equal to sigma by E. So in this case, epsilon 1 will be equal to sigma 1 by E. So epsilon 1 will be equal to sigma 1 by E So what is sigma 1, which is P by A1? So that will be equal to P by A1 into E. So how you are going to get this expression? So here, if you consider epsilon 1, which will be equal to P by A divided by E, so that will be P by A divided by E, that is E, so that will be equal to P by A into 1 by E, so P by A into E. So here the cross section is epsilon 1, so you will going to get A1. So here also you will going to get A1. So here you are going to get A1. So P by A1 into E is the formula. So the extension which can be found out. So what is the extension? Extension is given by delta L1, which will be equal to P into L1, P into L1 by A1 into E. So how you will be able to find out this? So with this you have already derived this equation in the earlier videos. So that is which we are considering sigma will be equal to sigma 1 is B1 given by P by A1. So epsilon 1 is given by delta L1 by L1. So when you are dividing this E is equal to sigma 1 by epsilon 1. So what we want is, so sigma 1 is P by A1 by delta L1 by L1. So when you are cross multiplying this, so this will be L1 by delta L1, which is equal to epsilon 1. So that is E, sorry. So this is going to be E. So what we want is E. So E is given by, so P into L1 divided by A1 into E. P into the delta L1 will be given by P into L1 by A1 into E. So this is the expression how you will be able to find out that the same expression what I have written here. So this is how you will be able to get it. Now the next point or the next section what we are considering is the second one. The second one is given to be section 2. So similarly with the same explanation we can do for this. So how sigma 2 will be equal to P by A2. Sigma 2 is P by A2, that is the cross sectional area at the second section, and then epsilon 2 is given by sigma 2 by E, which will be equal to P by A2 into E. And then delta L2 is given by P into L2 by A2 into E. Similarly, sigma 3, that is now we are going to consider the section 3 now. The section 3 is this one. 3, which is given by sigma 3 will be equal to P by A3. Then epsilon 3 is given by sigma 3 by E, which is P by A3 into E. Again delta L3 is given by P into L3 by A3 into E. So this is the third expression. So this is how we will be able to find out the stress, strain and the deformation of the stepped board for an individual section. But actually what we need to find out is it is for the entire section. So to do that, here we have the total change in the length of the bar. So total change in the length of the bar, total change in the length of the bar, which is given by delta L, which will be the total change. Delta L will be equal to delta L1 plus delta L2 plus delta L3. So that is again given by P into L1 by A1 into E plus P into L2 by A2 into E plus P into L3 by A3 into E. Now what we have is the common factor, because the load is same at each cross section which has been applied the tensile load, and also the Young's modulus of the material. See, since the stepped shaft has got the uniform material, so the same material, so E is going to be the same, so that will be equal to P by E into L1 by A1 plus L2 by A2 plus L3 by A3. So this will going to be the final expression for the total section or for the total member. But if the sections are made of different materials, suppose if you are considering the sections are made out of different materials, then what happens? Then naturally the variable will also be here. This is also one of the criteria wherein you are going to have the composite material. In such cases, wherein you have the two different materials are there in a single shaft, in such cases, if the sections are made of different materials, then delta L1 will be equal to P into L1 by A1 into E1. Similarly, plus then you have delta L2 which will be equal to P into L2 by A2 into E2. Then delta L3 is given by P into L3 by A3 into E3. This is considered when the sections are made of different materials Then, so what happens for the entire stepper shaft? So here, then delta L will be equal to P into L1 by A1 into E1 plus L2 by A2 into E2 plus L3 by A3 into E3. So this will going to be the final deformation or the extension of the bar.